Thank you.
Hello, and welcome to the 2026 edition of First Steps with Geant4. I'm pleased to welcome you to this course and to introduce to you Alvaro, who will be your course instructor. For those of you who are joining remotely, we hope that you'll be able to follow. If you have questions, please use Mattermost about technical questions or about things for questions for Alvaro. If you have the audio is not working, etc., or something similar like that, it's okay to use Zoom, but for all other questions, please use Mattermost. So I hand over to Alvaro now, and I hope that that everything will go as well as I expect it will. Thank you.
Okay. Good morning, and thank you, everybody. First, you can hear me well, both in the room and in remote. I guess so. Okay. So, as John said, welcome to this Geant4 course, First Steps with Geant4. This tutorial is intended for people that do not have much experience with Geant4, and the idea is to learn what are the minimal components to describe a simulation and to run it. The covering independently different fields from high energy physics, nuclear physics, medicine, space science, and others. This course, and as it was prepared, is mostly hands-on. That means that most of the time we'll be coding. The idea during these days, we will code our own app Geant4 application from scratch. And we will use only presentation to introduce the topics as we will be needing them. As I said, not much knowledge of C++ is required, but still we will need some to understand why Geant4 is built as it is, and most importantly, how to use it properly. We can start a bit interactive, both in remote and here in the room, by maybe defining what is Geant4 and for which purposes you might use it and for which purposes you might not. So first of all, and most important, Geant4 is a toolkit, not an application. It means that Geant4 provides you the building blocks to describe your simulation problem, and is responsibility of the user to program an application that will be executed later. These building blocks will be reviewed along this course. But Geant4 does not provide an application. It's a responsibility of the user to provide such an executable. Maybe we can start sharing the slides, even if I am not following them all the time. Okay, so let's start by the basic. Geant4 is used for simulation. Some of the algorithms are based on random numbers. Therefore, it's this algorithm also called Monte Carlo. As I said already, Geant4 is written in C++, but we will have to touch some other components too, just to configure the application. What Geant4 is not is a framework for doing reconstruction, but some of the Geant4 components can be used for reconstruction. Geant4 does not provide, is not a primary event generator, but the output of other primary generators can be fed into Geant4 application and be used. Although some very basic generators are provided by Geant4 and ready to use, those are very basic and in some cases are not enough. Geant4 is Geant4 provides several modules ready to use, but those are not validated. This is, again, a responsibility of the user once the application is done to validate the whole application to be sure that the output is meaningful. Geant4 does not provide a direct way, an automatic way to produce an output. Again, it's responsibility of the user to select the information that has to be extracted during the simulation and written out from the program. As a final note, because this topic happens quite often, Geant4 does not provide a way to read out-of-the-box CAD models. I understand that CAD is widely used for passive materials and sometimes, I guess, for modeling in modeling geometries or setups in other fields, but Geant4 does not provide a built-in module, but is rather easy to use, and the documentation is being expanded to explain you how to do it. Now, if the presentation sharing will be working, or I can share it from my side. I can share from my screen. Okay. May I share? Okay, so I will share. Yeah, it's very slow. From your screen. Sorry. Like that. Well. Okay. So I forgot to mention the content of this course is available in the GitHub project of Mihaly Novak, Geant4 Beginners course. Here you will be able to find the applications into different stages as we will be developing them, and the slides of the course that I will be also uploading to the Indico. The goal during this course will be to introduce the mandatory components that are needed to develop a Geant4 application, and some of the optional important components that can be used to extract information during the simulation. Sorry? Okay, thank you very much. Along the way, we will be showing you the main sources of information that can be useful when building a Geant4 application, mainly the user guide for application development and the Geant4 source code itself. And also, we will try to become familiar with the best practice when developing C++ code, in particular a Geant4 application. To do so, we will write together a Geant4 application from scratch. The setup will be extremely simple, but doesn't matter. It will consist of a box, and we will be able to configure the thickness and the material what it's made of. And also, we will be able to configure a source of primary particles, and the goal will be to collect the information regarding the energy that the energy that the particles deposit when they pass through this material. As I said, we will do this mainly by coding rather than presentation, and the presentations will be used just to introduce the topics as we will need it. The functionality on the application will be added step by step, and even if the agenda is more or less fixed, if you have any question or any curiosity, we will try to address it. And this is what we have to keep in mind during these 5 days. This is where we want to reach. Actually, we will reach this point on Wednesday already. What you see here is an event, one single event of a 4 MeV electron impinging in a block of silicon 1 centimeter thick. And the electron is coming from the left, and as soon as it enters the material, it will create many secondaries. And this snapshot, it was produced with a standalone application that we will develop together. So this is where we want to go. As I said, the main source of documentation are the different user guides. We will review now the installation guide, and during the course, we will be checking most of the time the guide for application developers. Any questions so far? Good. So we can go to the installation. So even if the virtual machine that was provided by the Bordeaux Institute has already installed Geant4, we will review how to install the Geant4 toolkit from scratch, because I believe the installation process is rather general and can be useful for many other projects, not only Geant4. And also, you don't have to be afraid of recompiling a code in case you need it. Now, what I hope everybody here has already the virtual machine. Does anyone have a problem with the virtual machine, or everyone have it working? So okay, thank you. Okay. So the main web page, the entry point to Geant4 documentation and other features. Sorry, I didn't clean my history. The main entry point will be this web page. My God. Okay. Sorry, this will be the main page. And from this web page, geant4.web.cern.ch, you can access the main parts of Geant4. Now we will start by reviewing the documentation. Here in the documentation, you can find on the right the menu. We will check now the installation guide, but then you have several user guides. Most of the time, we will be checking the application developers, but you see that there are others that can be of interest in a more advanced stage. So we can check the installation guide, and we can check what are the prerequisites. So in order to build Geant4, you don't need much apart from the source code that we can open in another tab that will show how to download it. We only need a C++ compiler and CMake as to configure the project itself. There are some features of Geant4 that are optional and require external libraries that Geant4 will only check that exist in your main operative system. For example, in order to use GDML as a persistency way of input-output geometry, one would need to install Xerxes library. And if you want to use some visualization drivers, of course, you need to install those. In our case, in our virtual machine, someone already installed this library, so we could use it. We could use GDML feature. And Qt is also installed that is used to create a Windows a graphical user interface. And for visualization, we will be using OpenGL. But of course, there are many other visualization drivers, and you will need to install them in case you want to use them. Now, to download it, again, this is from the main web page. On the top, you have several options. You have the download. You see that the latest version was uploaded in March. And in our case, we can download the zip code, the zip file with all the whole source code. Sorry. Yes. At the moment, you can do that in the virtual machine. This is just a drill. You don't need to do these steps. This is just for you to know how to do it. But this is not needed because the code is already installed in the virtual machine. I am just showing how to do it in case you needed to do it in the future. No.
So just to give you the context, the virtual machine is perfectly fine for doing the exercises, for prototyping a simulation. But once you want to deploy it, likely you'll outgrow what the virtual machine provides. The virtual machine is necessary for the fact that in order to have a course in which we have 20, 40, 60, 80 people, if the configuration isn't exactly the same, we spend our first 2 days trying to figure things out for everyone else. So for many simple uses, you could use it forever. But if you want to utilize it outside of the virtual machine, this is how one would do it. Many people have done it. Many people get other people to do it. But the effort is not massive. It's just that it's tricky for people who aren't familiar to get it ready for a course.
Okay. So what I will do is simply for demonstration purposes, there is no need for you to do. Now I move to the virtual machine. It's just for you to know how it is done. I will be using some bash commands. I will mention maybe some of them the first time I use them in case you are not familiar with. So when opening a terminal, I will do it from scratch. When opening a terminal like this, we will land in a certain directory. We can know in which directory we are by using this command here. Here it prints in which directory we are. We are in local1 directory, which is the name of the user, and also the password of this user in the virtual machine. We can use the command ls to list all the directories that are living here. We can go to downloads, where the zip file went. We can unzip the source code by using the command unzip. And pass as argument the zip file. By doing that, this command will unzip everything. Okay. If we list again, we will have now not only the zip file, but also a new directory that contains the source code, which is this one. And now you don't need to understand now, but we will use the CMake configuration tool to configure the build of the source code. To do so, we use the CMake command with the argument minus capital S to tell CMake where is the source code, and minus B with a name of a new directory where the project will be configured, where the configuration will live, and some temporal files will live. Sure. Sorry. I can do it bigger also here. Okay.
For others, it might also be more.
It seems that this does not work. Okay. Okay. So by simply using this command, as explained in the documentation that I closed, sorry. We can follow the installation guide, and I will do it similarly. So we can download the source code, we uncompress it, and then we use CMake as a tool to configure the project. for example, using this command. It's slightly different, but it does exactly the same. We can review the configuration options of a Geant4 build, for example, using the tool ccmake and passing as argument the build directory. You can see here the options, the user options that you might have. If you prefer a graphical interface that also exists, to install it is not installed here. You could do something like this to install it. Local one. Okay, in my case, I already installed it. You could do something like that. And with this, you will have a Qt interface of CMake that is a bit more friendly and allows you, for example, to look for options. Here you can see the different options of Geant4 itself. By default, it is compiled to be multi-threaded, but as you see, there are the Qt and X11 graphical interface and driver is disabled by default, as well as GDML. This is because it relies on external libraries and by default is not enabled, but we can enable it. For example, doing like this. And we can reconfigure the project. And now, okay. Sorry, I enabled by mistake. Okay, well, you saw what happens if you enable a package that do not have is not installed. So I enabled by accident Inventor Qt, which is another way of visualizing the geometry. And because the package is not installed, it triggers an error. So now I only marked Qt itself. And now you can see at the end that Geant4 will use Qt and will be configured to use Qt. We can generate the make files, and with this, we can close it. With this, the configuration step will be done. Now we can go into the build directory, and we can do simply make to make the project. There are more than 7,000 classes, and it will take in this computer more than 20 minutes to build. So let's assume that it was already built. I forgot to mention that the final products will be copied in an install directory. This install directory is specified by this variable cmake install prefix, and we can put here whatever we want. For example, what happened? Did it stop sharing?
Yep, you stopped sharing.
Oh, sorry. I think. Okay.
So can I have a question?
Sure.
1 second, let's. You can be heard.
Yeah, I already installed Geant4, but for example, I didn't activate the GUI interface.
Yes.
Can I only do that one, or you have to install from the scratch?
No, that is actually a very good question. You can always go to the build directory, and with this, there are several options. If you are younger, probably you will prefer a graphical interface like the one of the CMake GUI. When you pass CMake GUI and the address or the location of the build directory, you will be prompted with the window that you just saw with the options that were used to compile the project. If you enable or disable any of those, you can press again configure, generate to generate the new make files, and make again. And this will remake whatever component is needed.
So just for those who might not have heard the question well, if I want to change options like add a GUI or take away a GUI, can you do it in the same place? And as Alvaro said, the answer is simply yes. Sometimes you will say, I think that something broke in my compilation. You can clean it up and restart from scratch even, or you can, but you can also iteratively add things, especially.
Okay. Sorry, something I forgot to mention is the install directory. So once the compilation has finished and some final products are made, in form of libraries. You want to copy only those to a dedicated directory, install directory, and usually this is specified with the CMake flag, CMake variable, CMake install prefix, and you can modify this before or after. Sorry. Yes. Yeah. And you can specify this before or after doing the make. What is important is this has to be set up before doing make install, which is the specific command to copy those final libraries to the destination specified here. Okay, let's assume that we finished the compilation. We did already make install. I am not going to do it because also I will not be allowed. I don't have permissions to do it. And the installation directory is this one. Okay, from this point, you can follow me because this is what you will find also in the virtual machine. This directory, which you can also access by this environmental variable called Geant4 install. In order to use it, you have to put a $ symbol in front and the CD command just to move to that directory. So this install directory has 4 directories, as you can see here. The bin directory contains 3 bash scripts that are used in post-installation, but we will see another way for that. In order to build a Geant4 application, you don't need necessarily this, but these are very useful to use and know what they do. In the include Geant4 directory, you will have more than almost 4,000 public classes that are the public interface of Geant4. Some of the components are ready to use. Some of the components are just the interfaces. We will see later what it is. In the directory lib64, you can find the shared libraries that are compiled by Geant4. The classes are grouped by modules, and you can maybe identify some as OpenGL for the visualization, particles that contain all the information about particles, and so on. And the last one, which is also very important in share, typically, unless you change something, contains the experimental data, because some of the Geant4 physics models rely on experimental data to work properly, will be placed there. We can take a look. So, for example, radioactive data or some nuclear properties, nuclear structure properties, or other properties can be found here. And the other important directory in share is the examples directory. I would recommend you to take a look, maybe after the course, up to this basic directory. Contains 5 main examples, which are a lot with a lot of documentation, very basic, and is very nice to take a look. Extended examples contain more topical examples of certain parts of the toolkit. Typically, I would use them only if you want to know deeper about some part of the toolkit with an example, with code, because sometimes with the documentation itself is not enough. And advanced examples contain really advanced applications that are used in daily life, but you can leave that those applications for later. For the moment, if you want to start with Geant4 also after the course, I would recommend you maybe basic and extended only if you need some parts of the toolkit. Very good. Any questions so far?
One second, let's allow people to.
If we want to exercise with these basic samples, shall we copy the whole directory to our home directory, or how to proceed?
Thank you very much for the question, because that was exactly the next step. So thank you very much. Okay, so actually, once the toolkit is installed, we can try to copy and compile one of the examples just to be sure that we can compile and we can run it. We can take this example v1. So now we can go to our home directory. If we use the command cd only alone, we will go back to local1 directory, home local1 directory. We can create a new directory with mkdir command, and we will call it work, for example. We will move to that directory, and as it was said before, we can copy the example. Sometimes it's not needed, but we can do it with cp -r. -r is needed because this is a directory with subdirectories too, and we want to copy everything. This is placed in G4 install share Geant4 examples basic v1, and we want to copy everything, for example, here. So now, yes. So now in this directory, we have copied the source code of the v1 example. This is a full Geant4 application. We can take a look what is inside. Many files. But the important or the key point of this example, or what you have to keep in mind, because we'll be doing something very similar, is that there is a file called cmake list that contains the configuration of this application, of this piece of code, of this project. There is a main program named as example v1. You can call it as you want. We will see later. And then there are two directories, one called include and one called source. This is important. Most of the projects and applications that you will see will follow this schema, a cmake list and an include and source directories. Okay. So now we are still in the work directory. We have copy v1, and we can configure this in the same manner as we did for the Geant4 source code. To create a build directory and where the configuration of the project will live and the intermediate products will live, we can do like this, similarly to the Geant4 installation, cmake space -s, capital S, v1, which is the name of the directory we just copied, minus capital V, build v1, for example. The name doesn't matter. And we have to tell the cmake where the Geant4 is. To do so, we have to use, if we do nothing, after installing Geant4 we do nothing, we have to tell cmake where the Geant4 install directory is. Otherwise, cmake will be configured to find Geant4, but does not know where it is. So in order to tell cmake where it is, we have to use this variable. The alternative is to use one of the bash scripts that were living in the installation directory /bin, and those these bash scripts can be used as a post installation to permanently load all the Geant4 information, where it is placed, what are the components, and what was the configuration used at the build time. So we can do like this. And the v1 example could be configured. Now, inside the build directory, there is a make file, so we can we can do make, or we can use the make from the top to configure it, doesn't matter. We can go inside the build directory and we can type make, because it will take longer. We can try to exploit parallelism, so we can use this syntax to compile in 4 threads independently. Very good. Once it finishes, we can launch it. We can execute the final application. When we finished, it creates a final executable. We can execute the final application with /name of the executable like this. A lot of printout will be appearing there. Don't worry, you will understand in a few days. And this is the first example of Geant4. With this, we confirm that at least the visualization works. You can interact with the visualization if you want. And this is the Qt graphical interface, which basically allows you to use buttons instead of commands or C++ code. We can, for example, use this green button on the top. Thank you. We can use the green button to launch the simulation of one single event. And here we are. This is an example just to prove that the application works and the installation worked as expected. Sorry?
1 second, maybe.
I missed the button you pressed.
Sorry. Yes. So after launching the executable, here on the top bar, there are several buttons. We can press the green button. And if you see, the tooltip says run beam on 1. This is the command that you will need to use in case you were using the terminal. If we press the green button, you will see only one track. I don't know exactly what it is, but doesn't matter.
We'll go through this in much more detail.
Yes.
This is a preview.
I think there are some comments in the.
Can you read any?
Yeah, I think there were some comments in the Zoom.
Yeah, please, people on remote, if you have any questions, please use the Mattermost channel of the day one as it was broadcasted to you. In Zoom, we only use things for technical aspects. Okay, anyway, they have been asking how they can access Geant4, the Geant4 version on the VM.
On the VM? Yes.
The virtual machine.
Okay. Well, the name of the directory itself. I will show you.
The question is asked.
Sir.
I think the question was asked. All very good that you have a version of Geant4 on the virtual machine. How could they access the same version at another time? The simple way is that on the Geant4 website, this version that is in the VM is the most current one. It is 11.4 patch 1. And if you simply go to geant4.org or to the download page, that's the version that you will get. And then you can install it on your own machine using the installation guide, inspired by what was already demonstrated by Alvaro, which also was recorded. So if you want a future inspiration, you can go back to it.
Thank you. Okay. Any other questions? Okay. Good. So with this step, we confirm that Geant4 was properly installed and it works, and we can compile and run one of the examples. Now we will continue with the third point for today, which is a warm-up to introduce a bit of C++. I think one of the requirements of the course was a minimal knowledge of C++, but still we will go through some of the basic concepts of C++ that will be very useful for understanding better how to use Geant4. Okay, so for the next steps, we can close the browser. We are still in the work directory. We can create a new directory that we can call intro to C++. We can move into this directory, and we will be using the text editor Gedit to for editing the code this week. Of course, probably you are maybe familiar with other environments. Please use them as much as you want. This is very basic, but at least this is a common floor for everyone here. Common main, no, sorry. We will create a file called orapplication.cc, and we can simply put the name of the file after Gedit, and we can use the ampersand symbol afterwards, just to keep the terminal free. If without the ampersand, the terminal will be frozen, waiting for Gedit to finish. Using the ampersand, the terminal is still free to use to do things here. Very well. Now I will try to increase the okay. Does everybody see the numbers on the side and on the screen correctly? Yes. Okay, good. So we will start by the archetypical example when starting the programming, which is called printing in the terminal hello world. Okay. Does this example look correct to you? Or I am missing something? That is correct. So someone in the room already noticed. So in order to let the compiler know that we are using cout and NDL functions for streaming, we need to let the compiler know where it is or what we want to use. So in order to use C++ functions, we have to tell the compiler in the code where it is. In this case, this belongs to the STL C++ standard, and we can use it by including this header. Now to compile, very simple. You only have to use the compiler G++. You can use others, CLang, or the one provided in Windows, Microsoft Visual Studio. In our case, we will use G++, and we have to pass the sources and also the name of the final executable. We can write whatever we want. If we type this, now the code is compiled and an executable file has been produced, and we can call it like that. We can execute it as we did with the Geant4 example. And if we execute, well, we print out hello world. Very good. And now we want to start including parts of Geant4. So we will start slow, as slow as the internet connection. When we went to Geant4 web page in the download tab, in addition to the source code zipped, we had also the source code in GitHub. We can go to GitHub, and we can use GitHub as a way to navigate the code in a more user-friendly way. We will take a look to the file g4types.hh, which is placed here. Doesn't matter, because in the installation directory, it will be include Geant4. And we can take a look what it has inside. Inside this file, we only have, apart from a long comment with a disclaimer that if you use Geant4, it's under your own consideration, and Geant4 is not responsible for any misuse. What it contains is a list of aliases here, and a as you see, this is just alias on top of the standard C++, but you have to get accustomed on using this. If just in case in the future, Geant4 decides to change the G4 double for something else, it will be more comfortable for you if you simply use G4 double, and everything will be changed consistently. So we can use these types by sorry. We can use these types like this. Again, do I miss something by doing simply this? If I simply call a class that the C++ standard do not know, what should I do next? I need, exactly. I need to include the G4 types.hh as I did for the stdc out. And now we can try to compile and see what happens. Now the compiler complains because no such file or directory, because the compiler itself do not know where the header files are. So how to solve this issue? We can use the flag -I and tell where the Geant4 include header files are by passing this. And now finally everything works. Very good. This is what happens if we want to use a function of Geant4. For example, for streaming, we will use something very simple. Sorry. If we want to use, we can take a look to another header file, for example, globals.hh. I will try to make it bigger, otherwise. Okay. Okay, better. So this globals.hh header file is just a collection of other includes. It's an easy way to include in one shot many components of Geant4. We will include the streaming classes for Geant4, which are in this G4 eos.hh. We will include the G4 types that we just included. And we will include also the G4 string, which is just an alias of std string, and other components. It doesn't matter. And to use the Geant4 streaming, we can replace std ... by G4. And Geant4 streaming buffer is called G4 cout. And in order to terminate and flush the buffer, we can use G4 NDL. Now we save and we can go back. We can recover with the arrows up and down. You can recover previous instructions. We can try to execute again. And now we have a different error. But we have to learn to read the compiler errors because you will face this very often. So now what the compiler is telling us is undefined reference to G4 cout. Forget about the prefix and suffix. Basically now the compiler knows where is the header for this function, for this class, but does not know how to use it. Does not know where the implementation is. It's missing the shared libraries. So in order to let it know, in order to let the compiler know where it is, we have to pass also this option -L for libraries and where the libraries of Geant4 are placed. But also we need to tell what libraries we want to use. So we have to tell the compiler that we want to use G4 global. And yet it fails once more, but this time the error is different. Now, and actually the command that is triggering the error is not the compiler itself, but it's the linker. What it's telling us is that when using this library yet depends on another Geant4 library, but it will not be known at runtime. So in order to let the linker know at runtime where the Geant4 libraries are, we need to hard code them using this. And now we have to pass again, add the directory where the libraries are placed. So this instruction here can be read as compiler tell the linker in a permanent manner that the libraries of Geant4 are placed here. And now we can run our Geant4 application or an application that uses some components of Geant4, in particular the G4 cout and G4 NDL. Any questions so far? Okay. As you have seen, using this, passing all the compilation options to the compiler like this can be extremely error prone, is tedious, and does not scale well, because this is just Geant4, but if you have another application that depends on root, for example, you will need to pass, again, so many other flags that does not scale well. To make the life easier, Geant4 provides some tools in the directory. Sorry, this is on this. Well, sorry. In the Geant4 installation directory bin, you have some other scripts. For example, you could do before starting any session in the terminal, something like this. By doing this, I will not do it, but if by doing this, this will load a lot of environmental variables, and that will allow you to compile the Geant4 without passing at least the last part, but it still is tedious. You still need to pass many options. The alternative is to use another alternative, very fish, is to use this BAT script that can be used to extract what are the flags to be passed to the compiler. For example, as you see, many. Horrible to remember all of this. And also what are the libraries? What are the components of the Geant4?
Maybe people, at least one person has asked to see the source code again for a minute because they were having an issue.
The source code?
The editor the editor.
Okay, sorry. Yes, I can put it here. I can leave it open in a compressed manner. Okay. 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 So this Geant4 config bash script can be used to be called instead of all of these. Yes?
1 second.
What's the advantage of using, for example, G4 double instead of double from the standard library?
Maybe John can answer.
It's a convention in case in future we want to change the actual precision. It was a choice made almost 30 years ago. We've lived with it until now, and I think that it's conceivable that on future hardware you will get some things that have 48-bit precision and it's adequate, or so it's a convention.
Thank you. So as I was saying, it's very difficult to remember all of this. So Geant4 provides this bash script that we can actually invoke at the compilation step and can replace all of this by using this accent. There is no need. Okay. So you see with this Geant4 config script, it can replace all these flags that we were passing one by one to the compiler. You will see this in maybe a bit older applications if you have to use them. But nowadays, this has been superseded by CMake. And you will understand very fast why.
So this is a subshell expansion or something of this backtick that I see
yes,
there.
Sorry, yes. With the accent, it will evaluate this. It will evaluate this and it will pass everything in one shot to the compiler. So you don't have to do it by yourself. However, I am showing this just in case you see this in the future. You can recognize that it's just a way to pass the compiler all the Geant4 flags. But if you develop an application, you should not use it. Yeah. Okay. Yeah, sorry. There are two types of environment if you want. We are in bash, so we have to load the .ca, if I remember correctly. Sorry, we are not in bash, so we have to use the CH script. Good, but again, this is superseded now by using CMake, as we saw while compiling the example. So now I was just showing this because of historical reasons, because if you are dealing with an old application developed long time ago, you will see that they use this. Nowadays, we will use CMake. We could write the CMake file from scratch, but if we want, we can copy the CMake file from the V1 example that is just one directory app, V1, and then we have this file, CMake list. This file contains the configuration of the project that will be, and it will be used by CMake to configure the project itself and prepare the make files. So we can copy the file by using this syntax, cp.v1/cmakelist.txt. We can copy it here. Yes. We will have to change it a bit because, of course, it has the configuration of the V1 example, but we are not going to reproduce the V1 example. So by using gedit space cmakelist.txt. Oh, sorry. Yes.
Show the copy maybe first.
Yes, sorry.
Catch up. So we have someone who's lost who said that they're still getting a fatal error on globals.hh. No such file.
Sorry.
And then they're asking, weren't we meant to be doing the previous CMake file example correct first?
I think it's globals in plural.
They actually spelled it correctly as far as I can tell. So, okay, maybe I'll ask them to share with me what they're doing and I'll try and see if I can help them.
Okay. Anyhow, I was showing how to compile a C++ program that uses some of the Geant4 components, but still we will have to we can use CMake instead of all these tools to do so. So we copied the CMake list. I can show you again how to copy it. So we are in work in the directory home local1 work intro to CPP directory. In the directory app in work, we have intro to CPP, but also we copied the source code of the V1 example. And inside the V1, we have a CMake list. Okay, so what we are going to do now is to copy it by using the cp command /v1/cmakelist.txt, and we are going to copy it locally in the directory where we are, intro to CPP, where we have the or application.cc. And now we are going to edit it because, of course, this file contains the configuration of the V1 example.
Less busy.
Yes.
Make the VM full screen, and then yes, maybe even
okay.
make the terminal full screen.
Maybe better.
That might make things easier for people, both here and.
Okay, thank you. Okay, so we just copy the CMake list from the V1 example, but because it contains the configuration of the example, we have to change it a bit. We can use gedit to edit it, and we can go through the CMake. Don't worry too much about how it looks like. Just to mention that this function, find package Geant4, contains all the functionality to find the Geant4 components and to configure our project to link against the Geant4, as we will see later. As we saw, the example contained a source and include directory. We don't have any at the moment, but it doesn't matter. And now with these lines, we will create the executable. With the add executable CMake function, we will define our executable. Here we can put the name of our executable or application. And we can say where is the source code located, where is the main function. So our main function is in our application.cc. Don't forget about the rest because it's empty. Doesn't matter, will take no effect. Now, in addition to the name of the executable, this represents also a target, and CMake can assign properties to the target or can configure that target. In particular, for this example, with this line is telling CMake where the include directory is, and also, and this is again another very important line for you to remember, that our executable will be using the Geant4 libraries. Okay. And we can actually delete the rest because we don't have those configuration scripts. So the main changes were to rename the target, the executable. Instead of example V1, we put our application. We change the name of the source code, the CC file, and we tell CMake to compile our application against Geant4. Good. We save. This is source and include directories. Yes. We could do like this and it will work. We don't, at the moment, we don't need any of this.
So the question is what these sources and headers, those are things that will be added to the application. When you describe the geometry, you will do so in a different file. When you describe what to do with how to record information, you will do it in a different file in order to follow Geant4 conventions. So this will allow you, the CMake file, to find those files automatically without you having to type the name of each of those files inside the CMake file.
It doesn't matter at the moment. We will see how why we need this later tomorrow. Today will be too tight. So
are all the lines after 25 line deleted?
Yes, sorry, I think I forgot to mention, after the line 25, I deleted the lines in the CMake list because it will try otherwise to look for some scripts, so which we don't have because are only created for the example, and we can delete those. And this, it doesn't matter, we can leave it because we don't have the directories, so these lists are empty and nothing will happen, nothing will break. So now we have edited the CMake list. Now again, we can use CMake to configure the project. CMake space -S dot to tell where the source is placed. -B build, for example. So you see that Geant4 was found and is placed here automatically. This is because in our terminal, in our virtual machine, someone already placed source the geant4.csh file. Otherwise, we will need to add the CMake prefix path to G4 install. We don't need to type this in this virtual machine. In any other environment, you will need to. Okay. So now if we go to the build directory, again, we will see something similar to other cases. We see a make file and some other temporal information needed by CMake. We can type make. It will create our application executable file, which is this one. And we can again compile it. Execute it. So this is the main reason why CMake can simplify the compilation step. Basically, you can put all the configuration needed to build your final executable in a CMake list.txt file, and CMake will make sure to find the Geant4 or any other dependency that you might need. And you don't have to care to pass to the compiler all these flags to tell where is the include directory of Geant4, where are the libraries, or all these other features that we were doing manually before. Good. Any questions so far? It didn't work? What?
How many? If you were to use a different name for our application, because it's a little bit long to type, how many times do you need to repeat the word our application in your CMake file? And it's plenty.
Yes, if we take a look again to the CMake list file, we change it in 3 places. When we rename it for first time to create the executable, and then when we declare these properties, where is the include directory, we have to tell for which target, and when specifying the linking libraries, the libraries that will be used to link the project later.
And if we don't remove the lines after target lines, link libraries, then should it work, or we should have to remove them?
If I think CMake will try to look for the so those lines are used to look for some files, some configuration files that are used for the example, and because we don't have them. I am not sure if CMake will throw an error saying that these files are missing. You can leave it, and if the compilation, if the configuration breaks, you have to remove it. I would.
Okay, thanks.
Thank you. Okay. Here in the room, everybody has the CMake list and the main application that runs. Okay. Okay.
I'm still stuck at because globals.hh.
So the remote person is not the only person who's stuck. Okay. Others stuck? Okay. Okay. So it's a general problem then. So let's try and diagnose it one by one, and maybe we'll give the general result.
Okay. Shall we continue, or shall we make a break already?
It's up to you if it's a reasonable time. Since we have several people who are stuck, it might make sense to stop here, find what the problem is, and then
I think
take a. I don't remember how long we had set for the coffee break. How long?
Until 4.
Okay, let's break now until 3:35.
Okay.
Since we have a problem to solve.
Yeah.
If we find a solution, we will share the solution. When we find a solution, we will share it so people can come up to speed.
Okay, thank you. So shall we stop? Shall we stop recording, John?
I guess we need to stop the recording. Sorry.